Okay, in this video I'm going to be going over the wiring for the lab in Unit 9, the relay motor control. This is a pretty complicated lab, but if you take your time and work through it slowly, methodically, and follow these instructions, I don't think you'll have any trouble with it. However, if you just jump into the lab, you'll probably get stuck. So please follow this as I go through it. So let's start with the very left part of the circuit here. This switch is a normally closed switch, S1, and the normally closed switch is the brown one. It has this little lead soldered onto it, and one side is connected to 5 volts. So I'm going to put this kind of on the leftmost part of the circuit, and I'm going to kind of move around as I do this so you can kind of see my method here. Now I've interconnected all of my red and black wires for all the buses together on this whole breadboard. I can't remember if I went over that for this class, but I'd recommend that you do that. And if you do have any of these little gaps, to also make sure the red and blue ones are jumpered together. The red are going to be the positive, so that's going to be our 5-volt supply side, and the ground is going to be the negative. So if you wire it this way, if you hook all these up, you got lots of places that you can connect the power and ground connection pins to. So I plug that in, and now I'm going to connect the 5-volt supply, which is over here, to the input of that relay. Now, as soon as I make that connection, okay, and again with this switch, again, you want to make sure that it's plugged in this way so that the wires are side to side. So as soon as I make that connection, I'm going to mark it off on my schematic. Now you've got three or a PDF that has these sheets. I'd highly recommend you print them out. It's going to make it a lot easier if you kind of follow this process rather than just trying to build it all at the same time. And start with schematic 1 and work through the rest of them. So the next thing we have here is the K3 relay. There are going to be 4 relays you're using, and these are labeled K1, 2, 3, and 4. I'd recommend marking them if you can. And what I'm going to do, though, is plug them in kind of a sequence here from left to right. Now, the other thing that's very important, I think I mentioned this in the relay lab last week, is you want to use these sockets and plug the relays into the sockets. Make sure the leads are straight when you do this and push them in all the way. So when it's done, it's plugged in and it's solid. So those plugging it in that way to those sockets will really help keep everything stable when you're actually building the circuit. So that's K1. I'm going to plug it in over here. Okay, and I'm going to go ahead and plug in the other 4 relays, and then I'm going to move the video over a little bit to see this. So what's important, though, is that other side of the stop switch is not connected to K1, it's connected to K3. But the reason I'm going to put them in series, or kind of like next to each other, is just to make it a little bit easier to keep track of them as I'm wiring them. Okay, so I had to move things around a little bit so that it's a little bit easier to see the schematic and the board while I'm doing this on the video. There's a little bit of parallax on the screen, and so because of that, it looks like some of the numbers and the leads don't line up. But what I've done here is I've wired the 5 volts plus to the normally closed switch. The other side now is going to K3 pin 2. So I'm going to mark that off. Make that connection. And this is the method I'm going to use for wiring the rest of this. Let's take a look at the next one. So I'm going to go K3 pin 3, and I also, on the bottom of the sheet, there's this kind of little cheat sheet here to keep track of where the leads are. These are 2 pins spaced apart. These are 4 pins spaced apart. One of probably the biggest mistakes that people make in this lab is having a wire not quite plugged into the right place on the relay. So if something doesn't work, we'll kind of walk through troubleshooting this. But let me go through the rest of the connections here. So we're going to go to pin 3, which is 2 over, in this case, on K3. And we're going to connect it to K1 pin 2, all the way over here. There we go. So I'm just going to kind of double check these as I keep going along to make sure that they're correct and continue to mark them off. So that went over to K1 pin 2. And that's also going to connect to a normally open button. Okay, so I'm going to use this little push button here. Now I'm going to keep these in the next row just to make it a little easier. If you try to squeeze them in by the relays, it's a little bit squished. So I'm going to take that same connection point, which is K3 pin 3. By the way, you could, if you wanted to also, you could use K1 pin 2 there. Since they're connected together, it doesn't matter which one you use. But just for clarity, I'm going to go to pin 3 there, and I'm going to wire that to the input side of this push button switch right here. Okay? And again, I know it's a little hard to see. Hopefully you can kind of see this as I'm going along here. So I've wired up that part. Now, the other side of the switch, push button switch, is going to go to what? It's going to go to K1 pin 4 all the way over here. So that's K1 pin 4. And it's going to go to a couple other places. It's going to go to K1 pin 1. Now, since I've already got that plugged into K1 pin 4, I'm going to just jump it over to K1 pin 1. So again, the round circle represents the coil of the relay, okay, and these are the contacts. But the fact that it's both K1 here indicate that it's the same relay package. So that's what you got to keep track of. And finally, the other side of that relay coil, pin 8, which is all the way up here, I'm going to just jump her over to the black terminal there. Okay, so that's connected to ground. So I've completed that top part of the circuit. Okay. Now, on the schematic, it shows 1K. That's because we used to use a 12-volt circuit, but you can use a 330 ohm resistor for this orange, orange, brown. And I'm going to grab the green LED over here and make that connection. And I'm going to take that resistor and plug it into K1 pin 1, which is here, and run it down to here. A little hard to see with that wire in the way. And then I'm going to wire the LED to ground. I could use a jumper, but I'm just going to stretch the leads out a bit and do it like that. Now, if you want to do this, a little hard to see that. Maybe I can go over this way. That'll be a little easier to see. Now, you're welcome to change this up. Whatever way works for you is fine. But the basic idea here is that I've got the relays lined up, leaving plenty of space, and marking each connection as I go here. And the idea is that that way, if everything's connected together, I should be able to test this first part. And this is the latching relay part. If you haven't watched the video yet, you need to do that. And the PowerPoint, or I think I covered this in the PowerPoint. Make sure you follow the PowerPoint to see how this circuit works. Okay, so now I hooked up my power supply, and you want to use that third output on your power supply and connect the power to the red and the blue terminals. Mine is down below so you can't see it. So I've wired this up, and let's see what happens. If I press the red button, LED comes on, which latches, and if I press the normally closed button, it turns off. And you can hear the relay. You probably can't hear it on the video, but the relay clicks on and off. So I literally just wired that up and tested it, and it worked the first time. Now, I've wired this circuit before, obviously. I've taught this class a number of times. But the main reason that worked was because I was carefully, methodically going through the process of wiring it up. If you just try to wire the whole thing without keeping track of where you're at, you're going to have some difficulty. Now, you might wonder, what is K3 doing in the circuit at all? Well, we'll find out how that's actually applied when we get into the second part of the circuit. Now, on the second page of the circuit, you're going to wire in K2, which is... Now, on the second page of the circuit, you're going to wire in K2. And what's kind of easy about this is that we're seeing, and this is on the second page, so I haven't marked off all these connections yet with a highlighter, okay? But you'll notice that K1 and K2, the coils are in parallel. 1 is connected to 1, 8 is connected to 8. So we can simply wire those two coils directly across each other. So K1, I've got connected to, Make sure I'm in the right one there. Yep. 1 is connected to 1 right there. So that would be this connection here. And 8 is going to be connected to 8. So in that case, I'm going to run this jumper from pin 8 there over to pin 8 here. Now that isn't going to change anything in the circuit how it's working right now. But that's going to affect another part of the circuit that we're going to be getting into on the next page. So basically what we've done now is connected that. All the other connections have been made already. So let's take a look at page 3 here. Let me pull this out just a little bit. And focus. So let's take a look at the circuit. We've wired the whole top part and it's working properly as far as we can tell up to this point. Now we're going to kind of wire almost the exact same circuit, but you'll notice that there's some parts that are different, obviously. You've got switch 1 and switch 3 here, 2 different push button switches. And you're working with coil K3 and K4 and contacts K3 and K1. And I'm going to walk through basically how this whole circuit works in a video a little bit later on. But the point is now we're going to continue wiring this circuit exactly the way we were following the process before, but carefully marking off each connection as we go. Okay, so I wired up that schematic part 3 and found out one of my relays wasn't pushed in all the way. So that's something you want to check on for sure. But now let's see if this is working the way I expect it to. I'm going to turn on that first, the forward part of the circuit, hit the stop button, and if I press the reverse, it'll come on. And you'll notice that if I press the first one, nothing happens. Nothing happens if I press that. In other words, if I'm going to change direction, I need to stop the motor before I change directions there. So at that point, that's what your circuit should be doing. If it doesn't latch, in other words, if you push it and then you let go and the LED turns off, something's wrong. And that usually has to do with, more often than not, that has to do with the connections between the parallel combination of the switch and the contact. Because if this contact is pulling in, it should latch the circuit. Okay, let's take a look at the last part of the wiring. So we're not adding any more relays for this part. We're using existing contacts that we haven't used up to this point on relays K2 and K4. So let's see what's going on here. If none of these relays are on, the motor, which is represented by the circle with a positive and negative, is basically shorted out. If you follow this path here, and these normally relay contacts are closed, it'll short out the motor coil. Now what that does is that actually breaks the motor. This is actually used for regenerative braking in electric vehicles. They actually can find a way to short out the contacts. So without any power supply, the motor is kind of in a brake type mode. Now if we turn on relay K2, if that's energized, then this contact is off because that's the normally closed part of the relay, and current would flow through that contact. It wouldn't be able to go through this one because it would be open, through the motor, through the normally closed contact here to ground. And so that would be positive and negative. Now, if relay K4 is turned on, the 5 volts would flow through there. It wouldn't flow through this side because that's the normally closed side. It opens up and it comes back up here through the normally closed contact of K2 and to ground. So this circuit is referred to as an H bridge because it kind of looks like an H. More traditionally, it's kind of drawn like this, and that's kind of where the H pattern looks a little bit more familiar. So let's go ahead and wire this up. One thing that's important to notice is that you'll see on this side there is no pin 7. And that's what this is really showing, is that is the common lead of the relay. And then this is the normally closed and this is the normally open. So if we look at a traditional way of looking at a relay contact, if this was the normally closed on the top and this is normally open on the bottom, normally open, normally closed, and common, Then this pin 7 is the common terminal. The normally open side is pin 5 down here, and pin 6, should draw it here probably, be a little bit better. Pin 6 is on the top. So this is just a kind of a way to show, even though there aren't two sets of contacts, it's a single pole double throw type contact, but it's shown as two separate contacts, which is a common way of doing it in these kind of wiring diagrams. So let's go ahead and wire this up. So let's start with K2 and K4. We want to connect both pin 5 on those two relays to plus 5 volts. And I try to color code these. Sometimes we don't have enough wires, but ideally we want to use red for positive, black for ground. I've been kind of jumping around a little bit. But let's find out where those pins are. So K2 pin 5 is in the top left corner here. And that's going to connect to K4 pin 5 on that corner there. So that's connecting those two relays together. So I can mark that off. And then let's go jump over to pin 6 on those two relays. They're connected together also. So for K2 and K4, we're going to connect pin 6. And those are 2 in from the end. And those are ground, so I'll use a darker color for that. Sorry, it's a little hard to see as I'm doing this. But that's going to pin 6 for K2. And then I'm going to come over here and connect it to pin 6 on K4. And then that needs to be connected to ground. Now, I actually, when I made that connection, I didn't show that it was connected to the positive. I need to take those two pins 5 and go to the positive bus, which is up on the top there. So that's that positive connection. And let's take a look at the negative terminal, see if I can find a darker wire. And we want to go, we connected pin 6 together like this. We also need to connect those to ground. So I'm going to take that and connect it to the ground terminal there. Okay, so that's where having all these little bus strips make it a little bit more convenient. So this at this point, this is a bit of a mess, right? It's a lot of wiring, and that's why you got to kind of go through it slowly and carefully. Okay, so now the very last thing to connect is the motor, and you're going to connect those to pin 7 on K2 and pin 7 on K4. And once that's done, unfortunately I don't have a motor with me here. Once that's done, if the circuit is working as it was before, you should see the motor spinning in different directions when you actually press these buttons. So, a lot going on there. Let me kind of do a close-up, a little bit of a more close-up shot on my wiring. And I'm sure some of you can probably make this even a little bit cleaner than what I had on here. You also, if you run out of jumper wires or you want to make it even cleaner, you can use the 24 gauge wire that's provided with the different colors, strip those to specific lengths, and you could really make a clean job of wiring this. This is a little bit messy, but it's kind of the nature of breadboards. They aren't the cleanest, or they tend to be a little bit messy when you're wiring them up. Okay, so if you get stuck on that, let me know, but hopefully you'll go through this video and that'll help a little bit as you're going through the wiring.